So should I just X out of video? Okay. All right. Okay. Oh. We good to go? Good? All right. Hi, everyone. Sorry about the delay, but my name's Yash. I'm the director of Rowdy Creators. We're here to talk about cloud computing. Before we get started, I want to scope things out. What year are you guys? Freshmen, raise your hand. Okay, junior or sophomores, juniors. Okay, seniors, masters, PhD. Cool. All right. Okay. How many of you all have used cloud? Have heard of cloud? Any? You? Yeah, a little bit. Okay. All right. Another thing I wanted to say before we get started is at Intro to Tech we have workshops, but they're more interactive and they're hands-on. Unfortunately, cloud is such a topic that we couldn't necessarily do something that I'm doing on my laptop, and you all are following me doing that. But so just to throw that out there. But yeah, today's goal is not to necessarily teach you guys like how to be tool specific, or like I'm not going to show you guys like AWS specific ways of deploying services and whatnot. We're just going to be talking about the bigger picture. What is cloud? Why it exists? How did it start? And why is it important for software engineers to learn it, not just cloud engineers or DevOps engineers? So I wanna ask you guys, how many of you guys use Snapchat or have used Snapchat? And did you guys see that Snapchat was not working about a week ago or 2 weeks ago? You guys feel that? So the reason behind that was because AWS was having problems. All right, so let's start simple. Without knowing it, we all use cloud nowadays, whether we're streaming movies on Netflix, where you're watching YouTube, we're sending each other snaps, all these, I suppose, packets that we're sending over the internet are being, I guess they're being sent from a cloud or a server on cloud. And I would definitely want to let you guys know that when someone says cloud, it's not like one place that there's this massive computer at this one big server room. These are data centers connected over the world, and specifically over US. In the US, there's I think about 4 locations that Amazon has. Those are called availability zones, and each availability zone is essentially a data center. And a data center, well, I guess let me ask you guys, what do you guys think is a data center? When someone says data centers, like, what are you guys thinking of? Like a server room, right? Or is that right? Yeah. With the data stored. Yes, that's a good one. So, how many of you guys have actually logged on to the Fox servers? Anyone? Fox servers. Does anyone know what a Fox server is here? No? Okay, so when you guys get into, well, it's kind of unfortunate we don't really do C anymore, but essentially we had to compile code in C, and so we used to log on to our servers. So UTSA has servers, and they're called the Fox servers, and we can like SSH into them, meaning we can securely log into those servers using our terminal. Do you guys know what a terminal is by any chance? If you guys don't know what a terminal is, please raise your hand. No. Okay, terminal is essentially you're using the computer but with no graphical user interface, right? it's everything is there essentially, just not you being able to see the windows, you're not being able to click on buttons and stuff like that. Either way, I guess I won't use Fox servers as a example, but essentially at data centers there's two important things. One is compute and one is storage. So there's a lots and lots and lots of hardware that's able to store a lot of data, and there's a lots and lots and lots of computers that are able to compute, aka give people compute power over the world. If that doesn't make sense, that's okay. We'll decode it as we get into it. Yeah. Actually, I'm gonna move here. So before kind of getting into cloud and what it is, I want to go back a little bit and step back and talk about where did it start from, when did it start, not to be boring, but yeah, so we had, you know, the great dude Steve Jobs and Gates. These people came out with PCs, personal computers, where you could have a computer at your own service at home, which were portable. Times before that, computers were in a massive room with just a little screen, and it would take all that much to run this much of a, I guess, computer visually. But these people were able to pioneer personal computers now. People are, you know, working on their desktops at home, and these are local machines. You're not able to connect to the internet just yet. And then when the 1990s came, then that was kind of when the internet boom happened, and now people are kind of logging on to the internet. They're able to go to like go browse stuff. They're able to send each other stuff. There's a lot of forums, so a lot of people are talking over them, and people have their own websites, right? Like just plain basic HTML, and so that's up. And in the 2000s, now companies and enterprise like companies realize that we need computers and we need a lot of it. So a lot of companies were tracking their businesses over using computers, using code. So they needed a lot of storage. They needed to track how many users they had. And say if it was a bank, they needed to know exactly which transaction is happening at which second. So that's why the industry was adapting that, like every company must have a data center on their at their office, right? And so what came with that was a lot of machines, and a dude that looks somewhat like that used to take care of all the networking. So hooking up one server to another and creating a mesh network so they're all connected. And each wire mattered so much. Even if one was not in the right place, the entire system would be down, the business would be down for the rest of the day, losing a lot of money. And I also want to let you guys know that there were a lot of wires running out of the data center to everyone's desks. So there'd be like holes underneath their desks, and they would have an RJ45 cable. It's an Ethernet cable, if you guys seen it. It's kind of blue. Yeah, plugs in one of those looking things. And that's how they were able to access it. People were still not essentially doing it completely wirelessly. They were doing it wired until people, you know, started to work from the mountains in their homes, and that's when they kind of started to SSH into it, which is a protocol essentially where you're able to connect with a server or a compute where you're not there. So I will kind of use the Fox server. So I'm able to actually go onto the Fox server right now. Actually, this was not part of the plan, but I'll do it right now. So I can just simply open up my terminal, which, as you guys can see, it's just plain text. And matter of fact, I can't even use my mouse. If I click anywhere, I can't. It's just plain keyboard. And so I have an alias. It's like a little command set to do SSH. So if I did eSUI, now we have a server for ourselves, for enterprise software engineering on AWS, and we're able to go to that server through here. Now, the server is like in North Carolina where the data center is. I'm nowhere near it, and nor am I connected to it wired, right? But I'm able to send signals over the internet to use its computing power. Now, when I'm using a server, I'm not using my personal computing power. I might have the crappiest laptop, but I could be connecting to a, a computer that has like insane number of GPUs, and it has like 10,000 NVIDIA GPUs, and it's basically a rocket at that point. But as you guys can kind of see, so this is a server that I'm logging onto in North Carolina, somewhere in the data center, that AWS has in their server room. Does that kind of make sense to you guys? Any questions, please barge in. No need to raise hands or anything. Yeah, so that's kind of what happened. And then people figured out, AWS figured out that AWS, by the way, was the first company to market this, to pioneer this as a business. So they were like, all right, it seems like a lot of companies are having to spend so many, or they're having to invest in a lot of computing power. They have to buy servers and a lot of it. And they realized that, and they also had to, you know, each server room, like I mentioned, needed to be hooked up to wire. So you had to have good electricity, you had to have good network and whatnot. And another thing is, a lot of companies, like let's say Amazon.com, all right, the shopping one. When you're going on there, it's Thanksgiving. Let's, I guess, think about it in a more logical term. When it's like Thanksgiving, obviously their traffic is way higher, right? As usual, even in the usual days, a lot of people log on to Amazon to buy stuff. But if they have like some deal going on or whatever, so they have even more users. Now they have to accommodate for those users in terms of technicality, meaning they're having to send back their website packets so people can see the website on their laptops or on their phone. And Amazon created a company called Amazon Web Services, and the reason why it became such a big thing was because companies now were not having to buy servers by themselves. They weren't required to have data centers. They weren't required to keep the good temperature in the data center. It must be cooler than X amount. I'm not sure what the exact amount is. Cleanliness was a huge deal. Having a networking guy there always was keen, because if something went down, they needed to get to it right away so the business wouldn't go down. So what Amazon decided to do was, we're like, okay, we have a lot of these, now we're going to rent these out over the internet. And anyways, because as I mentioned, people started to SSH into them, meaning they started to communicate with these machines over the internet. And so they were like, why do these people even need servers if they're using the internet to communicate with those computers anyways? And that was the main idea behind companies starting cloud platforms and becoming providers. And then in the 2020s, now we're talking about, we've got this thing called AI, and everyone's talking about it. And so in terms of cloud computing, how it affects it positively is, now, as I mentioned before, compute had to be expanded or retracted based off of internet traffic. Now AI is able to foresee these things, and it's able to allocate those machines beforehand. So if they've seen data for the past 10 years, a company's been using AWS for the past 10 years, and they see, all right, so around Thanksgiving, around Christmas, this company is having a lot of traffic. So what it's doing is it's able to use that data, and it's able to set apart those computing resources for to be able to accommodate that, if that makes sense. All right. So that was a little bit of a background on that. Any questions, you guys? No? Cool. Give me 1 second. All right. And yeah, a disclaimer: cloud is not actually in the cloud. I think I should have began with that. But yeah. So what is cloud computing, right? So essentially, there's a lot of servers and a lot of storage and a lot of hardware, essentially, where you're able to reach to through the internet. And a lot of these companies have essentially made it a business. And it's a great business for a lot of companies that are looking to scale. Like I kind of mentioned, when it comes to occasions, they have more traffic. It is on demand. So whenever it detects the fact that it is needing more power, it does it for you. That's called auto scaling. And of course, there's essentially kind of how we use electricity. If I'm building a house and I want to be able to turn on the fan or the light, I'm not going and building a power plant in my backyard, right? I have a company like CPS that runs wires through my neighborhood, and I'm essentially using their power, and I'm paying for just that. And if I have the lights off, I'm not paying for that. And that's kind of how cloud computing works. Any questions on that, guys? No. Well, let me ask a question. Now, up until now, hopefully you guys have had the idea about it. What do you guys think is the difference between a server and the cloud? And I have a few refreshing treats from for you guys to think back to your childhood Kinder Joys. But yeah, can you say that again? That's a good answer. Not precisely. Anyone else? I will. Yeah. Okay. And what is the server? Because I asked, what is the difference between cloud and server? Yeah, you're almost there. Yeah. So essentially, a server is like a limited. It has limited amounts of compute power, whereas cloud, you're able to access it and have as many as you want. All right. So inside the cloud. Now, I've been repeating this a decent amount of times now. A data center essentially just has two main things: storage, like SSD, like how we have on our laptops, and compute. So, yeah. Any questions on what a data center is? Everyone knows. Everyone is a pioneer and a master on data centers. All right. Let's kind of get into virtualization and containers and orchestration. I I'm gonna draw some things over here to so you guys can visualize it. But essentially, the data center is essentially a warehouse filled with thousands of server and storage machines, and so yeah, that's a data center. Now, to kind of explain what is virtualization. Now, I've kind of mentioned the fact that we've got a machine, right? So let's say we're in location 1 for AWS, wherever that is, we don't care. And it's a data center, right? Like we've been saying. So there's many data centers there, and there's rows and rows, and you can walk through this massive data center. Now, I've mentioned, which I'm gonna say again. So some of them are storage, some of them are compute. So they have just the basic hardware like we do in our laptops, whether that's RAM, logic boards and motherboards and stuff like that, right? So each one of these computes, let's take a slice of this, right? Let's kind of go into what is a server now. So essentially a server is your laptop, but way more powerful with way bigger specs, way bigger, much more RAM and much more capabilities in terms of computing. It's nothing more than that. There's no magic behind it. But essentially, companies like AWS and Azure and GCP, Google Cloud Provider, realize the fact that, okay, we have a machine now, but is it really efficient for them to allocate one machine per customer? At the time, it was a great idea, and so no one really thought of it as a problem until they put their business minds to it and thought of it in the sense that, okay, what if we take this one massive thing and we split it up? What if we let a lot of people use that? So that's kind of when virtualization became a thing. Essentially, a server then would have, obviously, its hardware, right? Its infrastructure, whatever it is. And then it would have this thing called hypervisor. And a hypervisor essentially is a software that is able to distribute the compute power, and it's able to kind of schedule each jobs and send it to the hardware and use the hardware and be like, hey, I have this one process, I need you to do this computation, and then it uses the hardware to get that done, and then you get your results back. So hypervisor essentially is like a middleman between hardware and software in terms of a server. It's able to pick up on a job, give it to the compute does it, you take the results and give it back to the software, you take the next job, give it to the hardware, it computes what it needs to, you give the results back to the software, whether you're running a website or whatever it may be, a Python script. So yeah, so inside they were like, all right, so why not have many machines? So they created this thing called virtual machines, VMs. So a VM is essentially, in itself, a VM has its own OS, its own operating system, obviously, well, yeah, its own operating system, and it has, right, it has its own OS, and then of course, whatever application they were trying to run, right? So they have their app, so like their SRC, their source code, and then they have libraries and binaries. So not lid, but lib. So they would have supporting libraries or frameworks. So if I have a Python script, but I'm using fast API, so that would kind of like fall in here. I'm using a library or a framework of Python to help me with that. So essentially this would be inside of here, and there'd be several of those. Then they kind of thought of, okay, like this is cool, but they were seeing the fact that there were so many of these, and they saw a repeated pattern that every single one of them needed their own OS. Now they were like, okay, this seems to be very unintuitive, like not intuitive, because we're having to store OS, and this was becoming a bit of a detriment on storage at their data centers. They're having to store a lot of things for each VM to operate. So that's when we kind of moved from virtualization to containers. And so here's what a container is. So again, we have a server. Now, before I said we had many VMs, right? So this is a VM, and that would be in here, and there'd be several of them. And each one would need an OS, its operating system, whether it was Windows or Linux, whichever version of Linux. But to kind of eliminate the number of OSs they were storing, they decided to essentially containerize applications instead of putting it in a virtual machine in itself. So they created containers, and so this is kind of what the structure would look like. So they would have obviously they would have in the server, they would have their infrastructure, their wirings, their hardware, RAM, name it, right? GPUs, if that's kind of the one that, if it's a powerful machine that they're giving out. And then the OS, right? So this would be the host OS, and this would be the only OS actually running. So what they essentially did was they took this part and they brought it over here and put them inside containers, which all they needed was code, and it's supporting libraries and whatever that it needed. But just above the OS, they had this thing called a container engine. So they had an engine which kind of acted as a hypervisor, but for a hypervisor, the hypervisor would help the VMs distribute compute. The container engine essentially, well, yeah, I would say that is a hypervisor, but on a more higher level, because it's not having to, it is still like this will have processes which get passed on to hypervisor, and with the help of hypervisor, it will actually be able to use the hardware. Same thing happening with containers though. So no OSs, and it would actually use this OS, distribute it in every single container, use it there. And then also this kind of acted as a scheduler, kind of how I mentioned before. You have a sequence of jobs, it's like 1 and 2, like whatever the person is running, and there's like many processes. So there's several processes, and it's able to see, okay, like it was first in, first out. Have you guys heard of that? FIFO. And so whatever job came first through the tunnel, they were getting that done, give the result back, same ideology. So that's kind of where they ended with the cutting down on resources. What do you guys think now? Okay, so what do you guys think is the next step though? Anyone want to give me an answer? So before, they had a whole server to one client, and then they in the server they created a bunch of virtual machines. So that's kind of how they stepped into it even further, distributed it even further, and then they created containers, right? Got even closer to not having to use all these resources per application per client. Anyone want to guess what is the next step, or where kind of this is going? Well, that's a different matter, but yeah. There actually is nothing. That's kind of where it ends. We've only gotten down to containers. I shouldn't say only, because it was a very evolutionary thing when people were able to just make a container, put the application there, and now we just have one container, and now you can run several containers. And if you guys want, I would highly recommend looking into Docker. So Docker is a software which will help you create containers. I can actually go onto my terminal or download Docker desktop, and I can create containers within. So each container, in one container, I could have like a Python script running at all times. In the other container, I could have another Python script. In the other container, I could have a website being rendered. So that containers is something that you can run anywhere. And if you think about it, if you think about that nuance in terms of this, I have my machine, I have my own operating system, so I have a Mac OS in here, right? And I'm only downloading Docker desktop, which is essentially a container engine, which is able to help users create containers and put their applications within. Is that kind of clear? Any questions? No? All right. Orchestration. So essentially, there was this thing called Kubernetes. It's by Google. It's a software. It sounds very weird. Sorry, the text is a little small, but it's over here. That's kind of how you spell it. Is essentially a software that is allowing you to manage all those containers at once. So I have a container now. I have Docker, right? Now I could use Docker to bring up many more containers, and I could automate that. I can delete containers, but there needed to be a way for enterprise level software and for companies and enterprise to be able to give those services to their users. So they made this software called Kubernetes, which is an orchestration tool, and it kind of acts like a conductor, keeping like thousands of containers balanced and deployed and healthy. And here's what I kind of mean by that. Say there was some error that happened, and I have a container, and it's for this specific application. Let's take Southwest Airlines, for example. Okay, so now at Southwest, we're using AWS, and we've got several containers where we have Southwest.com's code. So that would be here, right? And its libraries. And let's just say for some reason it crashed because the OS messed up, or whatever it is, there were some OS problems, it crashed. Now, Kubernetes was a tool that kind of helps it bring it back up. Now, what it'll do is it'll actually scratch it completely, and it'll create a new container within the server. And how it's able to do that is by you actually, when you're deploying these containers, you must have a Docker file. Have any of you guys heard of Docker, by the way? Yeah, cool. Yeah, so they would create a container, and Docker kind of has their own language. don't know what it's called. It's like very so intuitive that I don't know what it's called. But yeah, they have their own, it's like a set of instructions, not even language, where you tell it, okay, so this is the app, here's the attached code, and here's what I need you to do for each container. And so that structure, scaffolding is kind of used to create another instance of a container if one goes down. And that's kind of what it means by keeping it healthy. So that's orchestration. Let me ask you guys a question. Why do you guys think companies build their own uh, data centers still? Or actually, I should say, why do you think companies build these massive like server farms, data centers, instead of having a one big supercomputer? Any ideas? Yeah. What? In case, yeah, that's a very good answer actually. In case things do get shut down. That's right. Can you guys pass that back, please? Thank you. So, yeah, when it comes to reliability, again, keeping things healthy and keeping things going, and also in terms of scalability, right? Let's think about it in that way. Now, you have a massive computer. Let's say we have 10 million people, okay? And our servers are made to serve 50 million people. Now, not only are you having to pay for the electricity bill all year around, no matter if your traffic goes up, and if it goes up, you're accommodating for that because you have more than you need, but you're having to pay the networking guy, you're having to pay the air conditioning, you're having to pay for all the electricity that data centers are using. Data centers use a lot of electricity. And so, yeah, for companies to not have to pay this much electrical bills and to keep those servers up, that's why they're able to just use cloud. So if they have just this much traffic at the hour, they're just going to have this much compute power. And then if they have this much traffic, like 60 million people pinging their websites, then the cloud compute or cloud providers that they're using will be able to auto scale the power and the number of instances as well. And there's also this other thing called scaling. Does anyone know has heard of scaling, auto scaling, anything? Yeah. What do you? Usage, allocate more. Right. Yeah, it's kind of in the name, right? Yeah. So that's right. Cloud providers are able to auto scale, meaning, and this is just like a company specific thing. So people say cloud providers are able to scale vertically and horizontally, right? When they mean vertically, they're talking about power. So if I only have, say, I'm a cloud engineer or a software engineer, DevOps engineer at Southwest, and I've said like, all right, this is the amount of like compute power that we need. Let's just put a very vague number on it, 50. And like this is how much we need. All right, but now I've realized that sometimes I'm not gonna need this much, but sometimes I'm gonna need even more. Where was I going with that? But yeah, So companies are, which is the reason why, again, companies are using cloud and it's able to, oh, right, I was talking about auto scaling. So, uh, and if AWS as a cloud provider detects the fact that, okay, now this server has too much traffic, and there's like a threshold that you can set personally, and you can allow AWS as your cloud provider to set for you. So say if it goes up to like 80%, it knows its protocol. So it would either increase vertically, meaning it would add on more RAM, or it would expand horizontally, meaning it would create a whole nother uh, computer, which would also have a threshold. And if it kept like kind of falling on that, so every machine, now I created a new one, it's at 80%, I create a new one, and that's kind of how auto scaling works. And which is a good thing because you're able to just pay for exactly what you use. How are we doing on time? Oh God. All right. So the important question is, why should developers care about cloud, and well, what does it mean to me? And me kind of tracing back to my freshman sophomore year, I used to think, okay, so cyber is for people that are doing cybersecurity, and software is for people that are doing software, and cloud is something that cloud computing students can worry about on their own. But the way this industry is kind of moving, software engineers are expected to have cloud knowledge because every single company is using cloud. Very few companies, very few like old school companies, namely not to uh, point at them, but Paycom, right? They kind of have a native system, and they're not really for the cloud idea, which is why they have their own set of servers. So they actually have a data center at their office, and even if offices like have multiple locations, they can still use the internet to get to that server. But yeah, so every company is using it, and it's very important for developers to know. And so infrastructure as a code, essentially meaning we can create servers and databases and networks using scripts instead of hardware. So there's a thing called HashiCorp language, HCL. There's a tool out there called Terraform, where essentially you can use that, and I can just go on my terminal right now and I can write a HCL script, HashiCorp language script, HCL script, and I can say I need this many AWS instances, and I'll also attach like a zip file with the code, so it'll know exactly where to put the code. I can also give it instructions, which instructions to run, like maybe to download dependencies once the code gets to those instances. And so this is something that's done a lot by developers because testing is a real thing. And once you get out in the real world, you can't just hit the run button and see what happens. You have to be able to see how your code is going to work in the real environment. So many of you guys may think like, okay, in terms of code, right? I have this one project. Okay, I have my website on here. I've got like this like main.html, main.cs, main.js, right? And several files. Now, many companies would have gone away from that. So, and then also like if you have a backend, which a lot of people use JavaScript to do backend work, right? To be able to maybe read from the database or to be able to call APIs, whatever it may be. Now, you still kind of live in one place, in one project folder, Now there's a thing which is kind of called monolith. Because mono, it means one, and that's kind of where everything used to live. If you go to someone's GitHub and if you go look at their project, you'll see that like all the code is there. And but in reality, it could be the fact that, you know, they were running some of these scripts in one container, some of the scripts in another container. So a lot of people like to, let's just take websites, for example, even Southwest.com, for example, airlines. They have their website in one set of servers in containers, and they have their APIs, meaning where are they getting the data, right? So they have the database, they have a script that reads from the database and passes it on to their front end. So the front end can display that. So that's kind of called microservices. They get distributed. So that is one of the key reasons. Another thing is global reach, right? So we're able to spread our software over the world. AWS has several locations. I believe 25 plus data centers over the world. I think every continent is wrapped with an availability zone by AWS. And so that's kind of the reason. And I've kind of mentioned the fact that, you know, being able to scale it up and down, and innovation without barriers just basically means if you're a software engineer at a company and you've got this great idea, it'd be kind of crappy to just have like the idea running on your laptop and just kind of scooting your laptop over to show it to your manager. Or in the real world, what actually happens is professionals are developing it and they're putting it on a container or a server, a mini server, and they're able to share that with many people. So that's kind of where innovation sparks when it comes to software engineering, and being able to kick off as many processes in machines is very needed, and it is very appreciated by several companies because, again, they've moved on to using cloud in the industry. Any questions, you guys? So why do you guys think companies like Netflix and Meta, Instagram, whatever, namely, rely on cloud infrastructure instead of their own servers? Anyone? Yeah, exactly. Yeah, makes sense. And that's exactly the reason. And I know this is kind of getting boring, like, okay, like scalability, but that is the whole point of cloud. We're able to expand and retract as much as we want. And kind of in the real world action, I wanted to show you guys a couple of examples. Netflix is, I don't, I did my research. I couldn't find anyone saying that Netflix has a single server that is owned by them and maintained by them themselves, like specifically. They're using AWS for everything that gets to you. So if there's a movie, these packets are like coming in sequence. And where is this compute coming from? This compute is being done at AWS. Where are the movies being stored? It's being done at AWS. So there's one service called EBS. It's called Elastic Block Storage. This is a very AWS specific tool. That's kind of where, or S3, whatever. There's many of storage services. That's kind of where it's living. And we've got a software now that's pulling that. So namely Lambda functions, which are essentially called function as a service. We'll kind of get more into that. I think the next slide is that. But yeah, Netflix is fully on cloud. That's all they ever use is cloud to get you the movie and for the tudum to happen. And NASA, it's actually storing all its telescopic images there. So when edge computing is also a great advantage to cloud. So when you've got such a small like machine, you don't have to maintain it. You're not having a million processes on there. So it's something that you can just use the cloud and you'll be able to store and globally access, right? Because again, the satellites are going everywhere, and having global reach, having all those data centers everywhere is kind of the plus point here for NASA. And like things like Udemy, YouTube, and Snapchat, kind of how we began at the beginning. So this region specifically, this location actually failed, which was the reason why you guys weren't able to snap your friends that morning. But they did fix it, so that's that. Kind of under the hood, there's a lot of categories. Now I know I said there's like two main things: compute and storage. Now, if you look at it, so EC2 is essentially a server where what you get as a user of cloud provider. Say we're using AWS and we kick off this thing called Elastic Container EC2. Elastic Cloud Compute is what it stands for, EC2, and essentially it's a Linux server, and I'm able to log on to it through my laptop. Obviously, again, there's no GUI, meaning there's no graphical user interface. I'm not able to click on buttons and whatnot. But when you're a developer, that's kind of how things work. And that's how machines should work as well, if you kind of think about it. Because just being able to show things visually, you're using a lot of computation, right? Like if you're having to show, like my screen right now is using power from my laptop, right? But if this wasn't there, then it could use a lot more power just to compute a lot of stuff. But so NEC2 is basically that. S3 is it's like a bucket. That's what they call it, S3 bucket. Again, this is an AWS specific tool. And does anyone know what S3 does? Any of you have cloud? No? Okay, so essentially S3 is, again, like storage. There's many others called EBS. And if you're talking about Azure, which is by Microsoft, that's their cloud company. They have this thing called Blob. GCP is Google Cloud Provider. So Google is also a cloud provider, and they call it storage. And you're able to store things there. And when we get kind of step lower, it says databases. Now, databases, if you truly think about it, neither does it really fall under like compute or kind of storage. I mean, yes, it's related to storage, but it's got a layer of software over the storage, right? So AWS has created DynamoDB, it's one of those database that they use, and now you're able to structurally store your data. Whereas if you look at the S3, you can just slap as many files there as you want, right? But if you have a database, now you can have like users, their emails and passwords and their files or whatever. Maybe it's just a more structured way of storing data. That's basically what a database is, and so they have they've made that available to AWS users. And Lambda functions and cloud functions, essentially, if I don't want a whole server, maybe I just want to invoke a script, maybe I just want to have a Python script run once per day, right? Do I need a whole server for that? No, right? Because again, what is the whole idea of cloud? It's to it's expand and detract to map exactly what you need. And if I just need a script running once per day, then I can have something like a Lambda function, which essentially you have your code there, and it'll be stored there on AWS. That's something you don't have to worry about. And essentially, whenever you invoke it, that's when you get paid. That's when you get charged for it. So per invoke, let's say, for instance, checkout button, right? Checkout button is like, that's a functionality that one could probably put as a Lambda function, or login. That's definitely a good one. So say a user has given me now their username and their password. Now I take it, I give it to the Lambda function. Lambda function goes in its code is written in such a way that it goes and reads in the DynamoDB or whichever storage it's using, sees, authenticates, gets back to the front end, and then the user is able to log in and whatnot. So functions that you just want invoked quickly, something like, so on an EC2, I can download libraries. I can download so many things. I could do whatever I want on there because it's a Linux like machine on the go. And there's a lot of things that you can do with that. But if you just want to run a little script, then you just might not want all that, right? So it's kind of that. If you haven't already explored into cloud, this is kind of one way I suggest. So of course, you've got to create a free account. So free account, every cloud provider has, to some extent, like free services. So EC2 is one of them for AWS, and to a certain amount of hours, they let you use an EC2 server for free. So you guys can like literally go home today, log on to AWS, start an instance, and now you have your own server in the cloud in North Carolina or in California or in Oregon, whichever location you've picked. So that's kind of one thing. Hosting a static website on S3. So I know I kind of mentioned like S3 is it's a storage, right? But how can you host a website on a storage? You can't normally, but it's just that AWS has set this up in such a way that, say if I'm storing an HTML file, I can quite literally, like, AWS will render it for me. So that way I'm not just seeing the lines of code, but like I can actually see the HTML rendered. So if I have like a mini landing page and that's the HTML code like file I'm putting in S3 just to store it there, of course it's being stored, but you can also make it accessible. That's an additional thing that you can do, in a step that you have to use to be able to see that code being rendered, essentially. A Lambda function is a great way. Maybe you guys can use like a weather API. So, and Twilio, I highly recommend you guys do that. Twilio is an API essentially that will text you on your phone. So I set this up for myself essentially just as a project. It's like a good morning, Yash. Here's a motivational quote. Here's the weather today. And so essentially, again, like kind of how I mentioned, if you have a script that's kind of just being run once per day, this is a great service to use. So Lambda is very easy to get into, and definitely explore cloud through. There's a course on Udemy. Every single person, I think, that has gotten the cloud practitioner for AWS has gotten this course. They've all been through it. It's this dude's named Stefan Marique, and he's a great explainer of cloud, and also specifically in AWS. But yeah. And the future, right? So right? We had the cloud come in. That back in the day, that was the future for people. Now that we had cloud, AI became the future, right? But now we're kind of living in that already. So now we're actually using AI, kind of how I mentioned in the beginning, that we're using AI to extract and detract services and compute power through AI, because AI is able to detect when you need it, when you don't need it. It can smartly do that. But yeah, so, and I kind of put like quantum there. I want to, can someone maybe think about why I said that? So a little bit of a hint. We use cloud. So if I want to use like a massive, I want to have a great GPU server, but I don't have the money for it, I can rent it through AWS, right? So I can access it through there. Maybe think about it in that terms. How could quantum kind of play a role in cloud computing? What do you guys think? Yeah. Qubits cost. Yeah. Not sure. Yeah, makes sense. Yeah, you're almost there. So now a quantum computer, if you guys haven't seen it, it's a massive machine like a chandelier. Now people can't have that at their houses, right? And they could have a server or two, right? That's possible. But even then, that's not really how things work, which is why cloud computing is a thing. But because quantum computers are so hard to maintain, they need to be in like negative 200 temperature, and they use a lot of electricity. They need a lot of surveillancing. Um, this hasn't happened yet, but when quantum computers are actually tangible, they're going to use the cloud to distribute the power that quantum has, so people like us can have access to that on the daily basis, right? If we want to explore, if we want to, maybe we're researchers in quantum, right? That's how they're going to be able to access some of those things. And these are kind of key takeaways. Know that you guys literally use cloud every single day. You pull out your phone, you go to Snapchat, it loads. It's think of it as like, okay, now it's going to AWS and it's going to the database. It's reading from my database that I created, or Snapchat created for me through code, and it's reading all my friends list, and then attached to that is all the photos of text messages that we've saved from the database, and I'm getting that back in such little time. It's doing that. So having good internet, this is kind of one thing I wanted to mention. Having good internet connection is very keen for cloud. And I mean, even for Save companies, Save Snapchat had their own server room. Us as users still need good network, right, to be able to talk to that, because we're not like wired to their servers. We're still talking to them over the Wi-Fi or the internet. It's accessible, and you can start free. You can build like quite literally whatever you want, from the smallest things to the biggest. Um, it it powers many companies like Snapchat, Netflix, NASA, like name it. Every company can. Someone give me you give me an example of a company. YouTube uses it all day. Matter of fact, you might be surprised. Companies like Apple, Apple uses Microsoft Azure as a cloud provider. They use AWS as a provider. They use Google Cloud Platforms as a provider. Many of these companies are also not just using one cloud provider, they're using several. So I didn't kind of mention this, but AWS is very, very, very good at compute. for giving you what you pay for, you truly get. It is worth it. Azure isn't the best in terms of getting a server for yourself. Azure is great to manage users, so like IAM, because Microsoft 365 and Google Cloud Platform or GCP is great at like providing data science related services through the cloud. That's kind of what they're good at, and those are kind of takeaways that I have for you guys. Is there like anything, do you guys think like maybe this opened a whole nother route of like a way of thinking to you guys? Or like personally, when I learned about cloud, it was like a lot of brain cells were unlocked for me. But what is y'all's take on that? We've kind of gotten to discussion anyways. Anyone? Do you guys personally think like cloud is kind of, I don't know, open something up for you guys, or it's like, oh, like, cool, I don't really care? What's your takeaway? Huh?
Why doesn't Apple?
Why doesn't, or why does it?
Why does it go via AWS, Azure, and all that?
Well, so iCloud is storage, right? iCloud isn't necessarily compute power, right? So if Apple wants, if I'm on apple.com and I'm buying an iPhone, I can surely have the pictures and all the text there on iCloud, but I need a server to render that. So when users come, they can see the code, right? They can see the website. So that's that. What about you? What do you think maybe helped you change or something new? Yeah. How do you keep this stuff secure? That's a great question. So not only has all these cloud providers come up with these services, they've also come up with a way of securing these things. So they have a lot of services for security measures as well. So one of them, namely, I'll say, it's not necessarily security, but I'm not a huge sec guy, so I wouldn't know. But API gateway is one thing. So being able to connect one AWS service to another and knowing that it can only and only talk to this is one thing. IAM is huge. Identity and access management. So us being able to, we can actually not only give, so if say Apple creates an AWS account, right, for the company, their organization account, now they have a bunch of users. So like if I'm an Apple worker, they are, you all are, we're all in there. So we also have permissions. So like this, so say Apple said that I can only access these specific services, but nothing from there because it's not related to my work. Now, not only am I actually being surveillanced by them, and not only are they able to take away my access or give me access, but they're actually able to give access to even services. So I can actually put like AWS Lambda and give it security measures. So like AWS Lambda can only talk with DynamoDB or EC2, whatever it is. Does that kind of make sense? And there's, of course, there's vast numbers of services on cloud to help with security.
So somewhere in the security.
Yeah. What about you? Any takeaways from you personally? Yeah. Do you have any questions? Anything that might need to be cleared up? Uh-huh. Well, that's kind of when you gotta trust the company. Now, what is stopping Apple from going on our iCloud? Nothing, right? Governance is what it is. That's kind of where trust comes in. Of course, they would never want to step into such legal issues that they're looking at people's stuff. But yeah, does that kind of answer it?
Yeah.
Yeah, just like how you trust your iPhone, right? I'm sure you do. You have iCloud turned on, so you've probably got a couple of messages or photos that are on there, right? How do you trust Apple to not look at those, right? It's just a matter of trust. It's something you have to, I mean, that we kind of sign up for when we create our Apple account. We're kind of signing up for that. That's all in the blueprints, right? In the small little text beneath create an account. So yeah. What about you, sir?
It's interesting to learn the history.
Yeah.
I really like.
Do you have any questions on anything that or anything history? Not really. Cool. So, what about you? What were your takeaways?
I really enjoyed, or I really liked.
Mm-hmm. Yeah, that's cool. And do you have any other? Do you have any questions? Here you go, man. Relive y'all's childhood.
Spread the wealth.
You good, dude. No questions? Cool. What about you? Any takeaways, questions?
I just fortunately I just think it's like cool to learn about it.
Yeah. Did you ever, so what specific field are you like targeting? Security, software engineering. Did you ever feel like, oh, this is something I'm never going to step into?
I mean, it's kind of just like never really entered my mind. I've just like focusing on.
Yeah.
It's like,
Right. It's so we first learn how to write code, and then we learn how to spread our code, how our code is actually being used, right? So that's what happens through cloud. Any questions? What about you? Mm-hmm.
right now, actually, I kind of feel like.
Oh yeah,
Um,
yeah, absolutely. Any questions? Anything I didn't do a great job on? No? Cool. I actually want to ask you guys a little question. Any review? Maybe how I can better myself as a presenter? I know I didn't ask a lot of questions. Interaction was a bit of a problem here, but there wasn't much I could have done with this topic. But anyone? Huh? Yeah, I realized different color pen would definitely would do it. Is there anything else? All right, cool. Thank you so much for joining in. I know it gets very boring, but I'm glad that you guys stuck around, and it's definitely a great, I suppose, spectrum and side in computer science to explore. And whether you're interested in security, software, AI, quantum, I think cloud is just not going anywhere. It's only going to help you and help all of these fields actually get to people. But yeah, thank you guys.